Right now, on your phone, a dozen apps are quietly talking to each other, and almost none of them were built by the same company. Your weather app is pulling live data from a government server. Your maps are coming from Google. When you tap Pay, your card details fly off to a bank you never installed an app for. None of these companies share a codebase. None of them sit in the same building. So how on earth do they all work together so smoothly? The answer is 3 letters you have seen 100 times and probably never had explained. By the end of this video, you will know exactly what an API is, how it works under the hood, and why basically the entire internet runs on them. Every app is an island. The code running your food delivery app has no idea what is inside Google's servers. It cannot reach into Google's database and grab a map. That data lives on someone else's computer, behind their walls in a form you cannot see. And that is on purpose. You really do not want random apps rummaging around inside a payment company's systems. But islands still need to trade. Your app needs that map. It needs today's weather. It needs to charge a card. So the question becomes, how do two systems that share nothing, no code, no database, no trust, safely ask each other for things? You need an agreed way to make a request, a doorway with rules. So here is the idea in one sentence. An API is a menu of things one program will do for another. The letters stand for Application Programming Interface, but forget the words, the one that matters is interface. It is the front counter. It is the set of requests you are allowed to make, and the promise of what you will get back. You do not get to walk into the kitchen. You do not see how the food is made. You see the menu you order, and a finished dish comes out. The company decides what is on that menu, what data you can ask for, what actions you can trigger, and everything else stays hidden and safe behind the counter. Picture yourself at a restaurant. You are hungry. The kitchen has everything you want, but you cannot just march in and start cooking. It is chaos back there, and it is not your kitchen. So instead, you talk to a waiter. You give the waiter your order. The waiter carries it back to the kitchen does the actual work, and the waiter brings your food out to the table. You never see the fridge, the recipes, or the mess. That waiter is the API. You, the app making the request, are the customer. The kitchen is the server, where the real data and logic lie. The menu is the list of things you are allowed to order. And notice what the waiter also does. They protect the kitchen. You cannot order something that is not on the menu, and you cannot wander in and change a recipe. The counter is a boundary. It lets two strangers do business without either one having to trust the other completely. This one picture explains almost everything about how APIs work, so hold on to it. Every exchange has two halves, a request and a response. Your app sends a request, hey, give me the weather for London. The server does its thing and sends back a response, the actual weather. That is the entire loop. Request goes out, response comes back. It happens in a fraction of a second, and it might happen dozens of times while you scroll a single screen. And here is the beautiful part. Your app does not need to know how the weather was measured, or where the servers sit, or what language they are written in. It only needs to know how to ask, and what shape the answer comes back in. Ask, receive. That is the whole dance. Let's zoom into one call and take it apart. A request has two main pieces. First, the address. This is called an endpoint. It looks like a web link, something like api.example.com/users/42. That is you pointing at exactly what you want, user number 42. Second, the verb, what you want to do at that address. Do you want to read that user? Create a new one. Update them. Delete them. The verb plus the endpoint is the core of every request. Read the user at this address. Create a new order at that address. Once you can read a request as a verb and an address, the whole thing stops looking like magic and starts looking like a sentence. There are a few basic verbs, and almost everything is built from just 4 of them. Get means read, fetch me this, and change nothing. Post means create, here is something new, add it. Put means update, change this existing thing. And delete means, well, delete it. Read, create, update, delete. That is it, 4 verbs that cover the vast majority of everything an app ever needs to do. And they are deliberately predictable, which matters more than it sounds. Because a get never changes anything, your app can safely retry it. Because a delete is spelled out as a delete, nobody removes your account by accident. The verbs are a shared vocabulary, so any two systems on Earth can understand each other. When you double tap to like a photo, that is a create. When you pull to refresh your feed, that is a read. When you edit your profile, that is an update. Every app you touch is really just a stream of these 4 little verbs, flying back and forth all day. Every response comes back with a number that tells you how it went, a status code. You have definitely met one, 404, the page not found error. That is a status code. Here is the whole cheat sheet. Anything in the 200s means success. 200 is the classic okay, here you go. Anything in the 400s means you messed up, you asked for something that is not there, or you were not allowed. 404 is that thing is not here. and anything in the 500s means the server messed up. 500 means something broke on their end, not yours. So before your app even reads the data, it glances at that number like a traffic light. Green in the 200s, keep going. Red in the 400s or 500s, something is wrong. Now, what does the data actually look like when it comes back? It is not a screenshot and it is not a web page, it is plain text in a format both sides agree on. The most common one is called JSON, and the reason it won is simple. It is readable by humans and by machines at the same time. It is just labeled pairs, a field name, then its value. Name Ada. Role admin. Active true. Curly braces wrap it up and you can nest one thing inside another, so an order can contain a customer who contains an address, all in one tidy bundle. When your weather app gets a response, it is a little package of this text, temperature, humidity, a forecast, and your app plucks out the fields it needs and paints them on the screen. Nothing about how it looks on your phone is in that bundle. The API sends the raw facts, your app decides how to draw them. That labeled bundle of text is the payload. Let's make one real request so this stops being abstract. Say we want to charge a customer $5. We send one line to a payments company's endpoint, with the amount and the currency attached. The server does the hard part, talking to the banks, checking the card, and sends back a bundle of text, an ID for the charge, the amount, and a status that says succeeded. That is it. That is a real live payment, and it is just a request and a response. This is exactly what Stripe, the company behind the pay button on a huge chunk of the internet, does. Their entire product is essentially one very well-designed API, and their documentation lists every endpoint you are allowed to call. Look at it and you will see the same shapes we just described: a verb, an address, and a bundle of text coming back. But wait, who let you in? If anyone could call the payment endpoint and charge cards, the world would end by lunchtime. So almost every real API asks you to prove who you are, usually with an API key. Think of it as a password for your app, a long secret string you attach to every request. The server checks it, sees that it is you, and then knows exactly what you are allowed to do and who to bill. Which leads to the one rule you cannot break. Never put your secret key in code that ships to the public, not in the app on someone's phone, not in a page in the browser. Anyone can pop that open and read it. Keys live on your own server, kept secret. Leak a key and you have basically handed a stranger your credit card. There is one more guardrail you will bump into: rate limits. An API will only let you make so many requests in a window, say 100 calls a minute. Go over and it starts turning you away with a specific status code that means too many requests, slow down. Why? Because their servers are not infinite, and one buggy app hammering them 10,000 times a second would ruin it for everyone. So APIs draw a line. If you have ever seen an app say, "try again in a few minutes," there is a good chance it quietly blew through a rate limit. The fix is not complicated. Do not ask for more than you need, and when you are told to slow down, wait a beat, then try again. Let's ground all of this in things you touch every day. That map inside your delivery app. It is not their map. They are calling Google's Maps API and drawing the result. The little weather widget on your home screen is calling a weather services API. When a chatbot on some random website answers you, it is very likely making a request to open AI's API in the background and relaying whatever comes back. Log in with Google on a new site. That is an API too, letting one company vouch for you to another. Even inside a single company, this is how the pieces fit together. The app talks to a payments API, an email API, a search API, each one a specialist behind its own counter. None of these teams rebuilt maps or weather models or a payments network or a language model from scratch. They just made a request, and that is the real superpower. An API lets you plug someone else's years of work into your app in an afternoon instead of a decade. Here's a number that reframes the whole internet. When researchers measured all the traffic flowing across the web, they found that the majority of it is not people at all. By one widely cited network study, more than 80% of web traffic is API calls, machines talking to machines, not humans clicking links. Every price check, every "is this username taken?" every map tile and autocomplete suggestion is a quiet little request happening behind the glass. The web you actually see is the thin, visible layer on top. Underneath it, a vast, silent conversation is running every single second, and all of it is APIs. A few things that will trip you up so you can skip the pain. 1. Read the docs, not your assumptions. Every API has its own menu, its own endpoints, its own field names, and the documentation is the source of truth. Guessing wastes hours. 2. Handle the sad path. Requests fail, the network drops, the server has a bad day, you hit a rate limit, and good code checks that status number and reacts instead of assuming every call succeeds. 3. Never trust data blindly and never leak your keys. Treat anything coming back over the wire as untrusted until you have checked it, and keep your secret keys off the public side. Nail those 3, and you are already ahead of a lot of working developers. So let's pull it together in 3 lines. 1. An API is a menu, the set of requests one program lets another make, with the messy kitchen hidden safely behind the counter. 2. Every call is a request and a response, a verb like read or create, an address, and a bundle of text coming back, stamped with a status number that says how it went. 3. It is how the entire internet cooperates. Your apps stand on the shoulders of everyone else's, one request at a time. If this finally made APIs click, do the one thing that helps this channel the most: subscribe so the next one finds you. And speaking of requests going out and answers coming back, what happens when the server wants to call you instead of you calling it? That is a webhook, and it is next in the series. I will see you there.